Hey there, young detectives, and welcome to today's Explainer. Today, we're going on an absolutely amazing adventure. We're going to become super sleuth detectives, and our big mission, well, it's to learn a secret code. But wait, this isn't just any secret code. It is literally the secret language used by every tablet, every phone, and every single computer in the entire world. So are you ready to crack the code? Let's get started.
Okay, let's dive into this. Have you ever wondered how a super smart machine actually does its math? I mean, think about it. Computers can play these incredibly amazing video games. They show us funny videos, they solve huge, complicated puzzles. But how do they actually count? They obviously don't have fingers or toes to count on like we do, right?
Well, underneath all those colorful games and the bright videos you love to watch, computers don't actually see pictures at all. Crazy, right? If you could peek right inside a computer's brain, you'd just see a giant never-ending wall of numbers. But not just any numbers. Look really closely at that glowing digital rain right in front of you. What two numbers do you see repeating over and over again? Yep, that's exactly right. Just 0 and 1. You see, humans like you and me, we use what's called a decimal system. That basically means we have 10 numbers to count with, ranging from 0 all the way up to 9, and we use them every single day. But computers, they've got their very own secret language, and it is entirely made up of just two numbers, 0 and 1. Nothing else. No 2s, no 5s, no 9s. This two-number secret code has a special name. It's called the binary number system. Now, binary might sound like a big, complicated science word, but it's actually really simple. Bi just means two. Think of a bicycle. Two wheels. So the binary number system is really just a fancy way of saying a counting system that uses only two digits, 0 and 1. So every single time you type a letter on a keyboard, the computer instantly translates it right into this secret binary code. Now, what's really interesting about seeing a finger pressing a button like that is why computers only use two numbers in the first place. Well, it's because computers run on electricity. Digital circuits inside the machine really only have two states. They can either be on or they can be off. It's exactly like the light switch in your bedroom. And that brings us to the absolute most important rule of our secret code. In a computer, a 1 means the switch is on. A 0 means the switch is off. That is literally the magic behind everything a computer does. When a switch has electricity flowing through it, the computer reads a 1. When it's dark and has absolutely no electricity, the computer reads a 0. Which brings up a pretty huge question. Can we really do computer math using just imaginary light switches? Like, can we actually add and multiply with only 1s and 0s? Well, yes, we absolutely can. And right now, I'm going to challenge you to do a real grown-up computer math problem using our new secret binary code. Don't worry, you are totally ready for this. First things first, let's look at our official detective rulebook for binary multiplication. We've got 4 simple steps here. Step 1, write the numbers down, stacking them on top of each other. Step 2, multiply each bit, which, by the way, is just a super fun computer word for a single binary digit, just like you would in regular long math. Step 3, shift the next row one place to the left. And finally, step 4, add all your results up. All right, let's see this in action. Okay. Here is the big challenge. Let's figure it out together, step by step. We are going to multiply the binary number 101 by the binary number 11. Remember, we're only dealing with 1s and 0s here, so this is going to be super fun. Step 1 is simple enough. We just write down the problem. Notice how we carefully align the numbers, putting the 101 right on top of the 11. We always line them up starting from the right side, exactly like you do when you're doing regular math at school. Just take a second to look at how neatly they stack on top of each other, right there. So the crucial point here is anything multiplied by 1 is just itself, right? So if we take our top number, 101, and multiply it by that first 1 on the bottom right, what do we get? We just get 101. So we write that down as our very first row. Easy peasy so far. Now for step 3, we take the top number, 101, and multiply it by the next one on the bottom. Again, anything times 1 is itself, so it's 101. But wait, remember our rulebook? For this second row, we must shift our answer one place to the left. By shifting 101 to the left and leaving an empty space on the right, it turns into 1010. Let's move forward and see how this all builds into step 4. The final step is just adding those two rows together. We stack them up neatly, 101 plus 1010. Let's pull the numbers straight down the columns starting from the right side. 1 plus an empty space is 1. 0 plus 1 is 1. 1 plus 0 is 1. And that final 1 on the left just drops straight down.
And ta-da! We get our final secret code answer, 1111. You did it! You literally just solved a binary multiplication problem exactly the same way a supercomputer does it. You use the secret code of light switches to do real computer math. Go ahead and give yourself a massive pat on the back for that. And you know, this brilliantly illustrates just how hard your devices are actually working. The central processing unit, which is basically the main brain of your computer, does this exact same light switch math we just did. But instead of doing it slowly step by step like us, it performs millions of these binary multiplications every single second. That's exactly how it runs your favorite games so incredibly fast. Well, you are officially a binary code detective now. You know that underneath all the amazing colors and sounds, a computer is really just turning tiny little switches on and off, reading ones and zeros, and doing super fast math. So I leave you with this final thought to ponder. What else can you multiply using just light switches? Keep exploring, keep decoding, and always keep wondering how the world around you works. See you next time on The Explainer.